viewers, welcome to VALARMATHI'S classes. In this video, we are going to see about sequences in algebra. We know that the meaning for sequence is some order in which things or events happen. Now here in algebra, sequence means some values arranged in some order. For example, let us consider this 1, 2, 3, 4. So here this is a sequence. Here 1 is the first value, 2 is the second value, 3 is the third value and 4 is the fourth value. That is 1 is followed by 2, 2 is followed by 3 and 3 is followed by 4. So now in this way we can represent a sequence. That is, we have to write down the values and we have to separate the values by using commas, and we have to use curly brackets at the beginning as well as at the end of the sequence. So here one thing is to be noted, that is, while writing a sequence, the order of the values present in the sequence is very much important. That is, we have to write the first value at the first only, the second value at the second only. So now if I am going to change this in this way, if I am writing this 3 at the second position and if I am writing this 2 at the third position, here this sequence will not be same as this sequence. Both will be different. That means we should not change the order of the sequence. If we change the order of the sequence, we'll lose our original sequence. Okay, now here this 1, 2, 3 and 4, they can be called as elements of the sequence or terms of the sequence. So now in the sequence we are having 4 terms, 1, 2, 3 and 4. Okay, so now in the case of sequence, one more thing is to be noted, that is, within the sequence the values can be repeated also. There is option for that also. Okay, so this is some introduction about sequences. Now the next we can see the types of sequences. Types of sequences. Based upon the number of terms present in the sequence, we are having 2 types of sequences. The first one is finite sequence. Finite sequence. So now here, finite sequence is a sequence where the number of terms is finite. For example, let us consider this sequence 1, 2, 3. So here the number of terms is 3. So it is a finite number. So we can say something about the number of terms. That is, there is an end to the sequence. So if we are having such a sequence, we can name it as a finite sequence. That is, there will be an end to the given sequence. That is, we will be able to specify the number of terms present in the sequence. So such a sequence can be named as a finite sequence. Now the next type is infinite sequence. So in the case of infinite sequence, we cannot say anything about the number of terms present in the given sequence. So here it is 1, 2, 3 and etc. So we cannot say what will be the end of this sequence. So we cannot say anything about the number of terms present in the sequence, and also there will be no end to the sequence. So such a sequence can be named as infinite sequence. So these are the 2 types of sequences based upon the number of terms present in the given sequence. So we can see one more example to know the difference between this finite sequence as well as infinite sequence. So here in the case of finite sequence, we can consider a sequence of natural numbers less than some 5. So here a sequence of natural numbers. So the natural number starts from 1. So a sequence of natural numbers less than 5. So 1, 2, 3, 4. So we cannot consider 5 because here it is less than 5. So the sequence will have all these numbers, that is 1, 2, 3 and 4. So here in this case there is an end to the sequence. So this becomes a finite sequence. Now here in the case of infinite sequence, we can consider this example, that is a sequence of natural numbers. So here the natural number starts from 1. So it is 1, 2, 3. Here there is no condition specified. Just it is given as a sequence of natural numbers. So here there will be no end for this sequence. Since it is a sequence of natural numbers, it will be going on till infinity. So now this comes under this infinite sequence. So this is an example to show the difference between finite sequence and infinite sequence. So in this way we can consider many examples. Okay, so now let us consider this sequence. It is a sequence of numbers 2, 4, 6 and 8. So here there are 4 terms. So in order to differentiate the position of the terms, we can use any variable. So let us use the variable some n. So for this position, the value of n, let it be some 1. So for this position, let the value of n be some 1, and for this let the value of n be 2, and here the value of n is equal to 3, and here the value of n is equal to 4. So now here this n represents the position of the terms present in the sequence. So here we have used the variable n because it takes different values based upon the positions. So in order to represent that or to denote that, we have used the variable n here. Okay. Now similarly, in order to represent the terms also, we can use a variable. So let it be some x. So in order to differentiate the terms, we can use n here. This n is nothing but this variable. So for this first term, it becomes x1. Here in the place of n, we will be having 1. So it becomes x1. That is x1 is equal to 2. And coming to the second term, here it is n is equal to 2. So x2 is equal to 4. Similarly, for the third, it is x3 is equal to 6. And for the fourth, it is x4 is equal to 8. So these are the terms. Okay. So now this n represents the position of the terms, and this xn represents the terms present in the sequence. Okay, so now when any sequence is given, we can bring out a general expression for the terms present in the sequence in terms of the variable n, that is the position of the terms present in the sequence. So we can see how to do that, and also we can see what is the use of bringing out the general expression for the terms. We'll see one by one. So now we can see how to write down the general expression. So here it is 2, 4, 6 and 8. When the value of n is 1, the term is 2. When the value of n is 2, the term is 4. When n is 3, the term is 6, and when n is 4, the term is 8. Actually, what has happened? When we multiply this 1 with 2, we will get 2. When this 2 is multiplied with 2, we get 4. When this 3 is multiplied with 2, we get 6. When this 4 is multiplied with 2, we get 8. That is, 2 is multiplied to the value of n, and we have obtained the terms. That is the meaning. So what we can do is, we can write down the general expression for the terms, that is xn, as xn is equal to, so here it is n into 2. So in the first case, when we multiply 1 into 2, we get 2. Second case, when we multiply 2 into 2, we get 4, and it goes on. So xn is equal to 2 into. Okay, so now we have got xn is equal to 2n. Here one more thing is to be noted, that is, we should not leave this as such, because if this is the expression, what happens here when we substitute the value of 1 for n, it becomes x1 is equal to 2 into 1. So it is equal to 2, and x2 is equal to 2 into 2. So it is equal to 4. x3 is equal to 2 into 3. So it is equal to 6. 4 is equal to 2 into 4. So it is equal to 8. And will be going on continuing, that is x5 is equal to, it will be going on, because there is no specification about the value of n. So we will be going on writing all the values. So this will not be the expression for this. So now in order to bring out the correct expression for this, what we have to do is, here we are having the value of n is equal to 1 to n is equal to 4. That limits should be shown here somewhere. So what we can do is, here we can use brackets x n is equal to 2n. Here the value of n is equal to 1 to, here it is 4. This is a lower value and this is a higher value. So it becomes xn, for n is equal to 1 to 4, it is equal to 2n. So automatically it becomes, we have to substitute the value of n is equal to 1 till 4. So first we have substituted the value of n is equal to 1. We have got the value of x1, and the next case it becomes x2, and the next it becomes x3, and the next it becomes x4. That is the last value. So we will be stopping here. So there is no need to continue. So now this becomes a expression corresponding to the terms present in the given sequence. That is xn, for n is equal to 1 to 4, it is equal to 2n. Okay, so now if it is given, write down the sequence corresponding to this expression. We can use this method and we can bring out all the elements and we can bring out in this form as a sequence. Okay, so this is about sequence. So now if this is a given sequence, we can see how to bring out the general expression for the terms present in the sequence. Okay, so now here as usual, n is equal to 1 for this first term, and here it is n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and here it is n is equal to 6. Okay, so now we have to bring out the general expression for the terms. Let us consider this xn for the terms, and here when n is equal to 1, the term is 3. 1, it is multiplied by 3 and we have got 3. When n is equal to 2, we have got 6. 2 into 3, it is equal to 6. N is equal to 3. So 3 into 3, it is equal to 9. So, and here it is 4 into 3, 12, 5 into 3, 15, 6 into 3, 18. That means 3 is multiplied to the value of n and the corresponding terms we have obtained. So what we can do? We can write this x equal to 3 into n. And here there is a limit. It is still n is equal to 6. So we can write down xn for n is equal to 1 to 6. It is equal to 3n. So now this is the general expression corresponding to this sequence. Okay, so now if the given sequence is 3, 6, 9, 12, 15, 18, etc. We can see how to bring out the general expression. So here we are having the same thing, n is equal to 1, n is equal to 2, n is equal to 3, and it goes on. So 1 it is multiplied with 3, here 2 multiplied with 3, 3 multiplied with 3. So the same concept. So in order to bring out the general expression, we have to write down as xn is equal to 3 into n. But coming to the limits, here it is n is equal to 1 to 6. Here we do not know the final value for n. So it is infinite. So what we can do? So xn, here while writing the limits, we can start from n is equal to 1 and the upper limit we can use infinity. This is not known. So xn for n is equal to 1 to infinity is equal to 3n. So now this is a general expression for the terms corresponding to this sequence. So now if we are asked to bring out the sequence from this general expression for terms, we can see what to do. So here the value of n, it varies from 1 to 6. So we can write down when n is equal to 1, x n is equal to x1. So x1 is equal to, here 3 into 1. So 3 into n. So it is equal to 3 into 1. So it is equal to 3. So for n is equal to 2, x2 in the place of n we will be getting 2. x2 is equal to 3 into 2. So it is equal to 6. When n is equal to 3, x3 is equal to 3 into n. So 3 into 3, so it is equal to 9. When n is equal to 4, x4 is equal to 3 into 4. So it is equal to 12. And when n is equal to 5, x5 is equal to 3 into 5. So it is equal to 15. And when n is equal to 6, x6 is equal to 3 into 6. So it is equal to 18. And we have to stop for n is equal to 6. So we have got the values for the terms. Now next step is the sequence corresponding to the given expression for terms. It is 3, 6, 9, 12, 15 and 18. So in this way, if the general expression is given, we can bring out the sequence. If the sequence is given, we can bring out the general expression from that sequence also. So in this case, if the expression is given and if you are asked to find out the sequence, we have to proceed in the same way and we have to find out x7, x8 and it will be going on. There will be no end. So the sequence becomes, here it becomes 3, 6, 9, 12, 15, 18. It will be going on. There will be no end. That's all. So now we can see what is the use of bringing out this general expression for the terms present in the sequence. Now let us consider this sequence. We have brought out the expression for the terms present in the sequence. What is the use is, if we are asked to find out some particular term, we can easily find out by using this expression. For example, here it is n is equal to 1, n is equal to 2, 3 and it is n is equal to 4. For this, here it is n is equal to 5, n is equal to 6 and it will be going on. If we are asked to find out the 10th term, we can easily find out by using this expression. That is, if this sequence is given and if we are asked to find out the 10th term of this sequence, what we have to do is, we have to substitute the value of n is equal to 10 in the general expression for the terms and we can bring out that particular term. That's all. So, we have brought out the expression corresponding to the terms present in the sequence. It is xn, n is equal to 1 to infinity is equal to 3n. So, in this case, we are asked to find out the 10th term. So, what we have to do is, we have to substitute the value of n is equal to 10 in this expression. So, the term becomes 10th term is equal to x10. N will be equal to 10. That is, n is equal to 1 for the first term, 2 for the second term. So, for the 10th term, the value of n will be 10. So, for the 10th term, the value of n will be 10. So, the term becomes x10. So, x10, it is equal to 3 into n. So, 3 into the value of n is 10. So, 3 into 10, it is equal to 30. So, the 10th term of this sequence is 30. So, we can easily find out in this way. If we are asked to find out, for example, some 22nd term. So, it is equal to x22. So, x22 is equal to, so 3 into n. So, 3 into the value of n is 22. So, 22 is equal to 66. So, this 66 will be the 22nd term present in the sequence. So, in this way, we can easily find out the terms present in the given sequence if we are having the general form or general expression for the terms present in the sequence. Okay, so now let us consider this sequence 3, 5, 7, 9, etc. Now, if we are asked to bring out the general expression for the terms present in the sequence, we can see how to proceed. So, here n is equal to 1 corresponding to this value and here it is n is equal to 2, n is equal to 3, n is equal to 4. Okay. So, now here we have the first value as 3. Here it is n is equal to 1. So when we multiply 1 by 3, we will get 3. That is, we are multiplying 1 by 3. So we will be getting 3. That is 1, it is nothing but n. Now coming to the second case, n is equal to 2. 2 into 3, it is equal to 6. But we have 5 here. So this 6, it is not equal to 5. So we cannot go by this way. So we can see whether there is any other way to bring out the value. So now here n is equal to 1. It is 3 here. So now let us multiply by 2. So n is equal to 1. So when we are multiplying this n by 2, it becomes 2 into 1. It is equal to 2. So now we can see whether there is any way to bring out 3 from this value. So when we add 1 to this value, it becomes 3. So now we can see whether this concept works for the other cases also. In the second case, n is equal to 2. So 2n, it is equal to 2 into 2. So it is equal to 4. So if we are adding 1 to this 4, it becomes 5. So we have got the second value. So we can check for the next one also. N is equal to 3. So 2 into n. So it is equal to 2 into 3. It is equal to 6. When we add 1 to the 6, we get 7 and we have 7 here. So this concept works here. So what we can do is, first we have to multiply 2 to the value of n and then add 1 to that product. And we will be getting the corresponding terms. That means first we have to multiply 2 to the value of n and then add a 1 to that product. So that becomes the term. So it is, the term becomes xn. So the term is xn is equal to 2 multiplied with n plus 1. Now we have to write down the limits. So here it is n is equal to 1. Here it is a infinite sequence. So here it becomes n is equal to 1 to infinity. Okay. So now this is the general expression for the terms present in this sequence. So now using this general expression, we can find out any term present in the sequence. If we are asked to find out the fifth term, for example, it is 3, 5, 7, 9. The next term should be, actually here 2 is added to all the terms. So 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9. So 9 plus 2, next term it becomes 11. So we can check whether we are getting this term or not. So we can find out the fifth term for n is equal to 5. So it becomes, when n is equal to 5, xn is equal to x5 is equal to, we should get 2 into, in the place of n it becomes 5. So 5 plus 1. So it is equal to 2 into 5 is 10. 10 plus 1 it is equal to 11. So we have got this term. So in this way we can find out any term present in the given sequence if the general expression for the sequence is given. If you are asked to find out some 13th term, we can use 13 here in the place of n. So here it becomes 2 into 13. So it is 26 plus 1. So it becomes 27. So the 13th term of the sequence is 27. So similarly we can find out any term present in the given sequence. Okay, so we have seen about sequences, the types of sequences based upon the number of terms present in the sequences, how to bring out the general expression for the terms present in the sequences, and how to bring out the sequence when the general expression is given. So we have seen all these topics. In the next video, we will see the special types of sequences one by one. Thanks for watching this video. We will see the continuation in the next video.